Hello there. In this video, I'm going to use the depressed cubic approach to solving for the solutions of a cubic formula. And what we're going to find over the course of the video is this is equivalent to choosing between, do you want to solve a quadratic using completing the square, or do you want to use quadratic formula? This process is ultimately how the cubic formula is derived. And so after that, it becomes a matter of preference. Thank you to the viewer who suggested I try this. It was an interesting learning experience. It was not easy, and I don't find that it's necessarily quicker or easier than using the cubic formula. It's just all about preference. And with this, you wouldn't have to memorize a formula. Okay, so how do we depress the cubic, and what does it mean to be a depressed cubic? Well, a depressed cubic means we need to make this square term go bye-bye. Okay, we don't want it in there anymore. We just want a cubic term, we want a linear term, and we want a constant term. Well, the formula, the magic formula we use for that is to take x and set it equal to y minus b over 3a, okay? I'm not going to show how this is derived. If you would like to see that in another video, let me know. So let's remember that a is 2, b is equal to -6, c is equal to 5, and d is equal to -3. So our substitution would be x equals y minus b is -6, and then a is 2, so that's 3 times 2. Well, simplifying this, negative, that'd be y plus, and then we get 6 over 6 would just be 1. So what I'm going to do is I'm going to take y plus 1 and I'm going to sub it wherever I see x. So really quickly. Okay, great. So what we're going to expand, distribute, and come back together. So okay, great. So let's find the terms and combine them. So I noticed that my y squared term simplifies as it should. I got a linear term of 6 here, subtract a 12, and then add a 5. So 6 minus 12 is -6 plus 5 is -1. So we get 2y cubed, there's no other cube term, minus 1y, and then let's look at the constants. We get a positive 2 minus 6, that'd be -4, plus 5. So -4 plus 5 is 1, minus 3 is -2 equals 0. Okay, let's transfer this. Now, the next step of this process, if you try to use, say, a rational zero test or maybe Newton's method at this point, you could do that. But if we were going to use Newton's method, we could have just used it from the beginning. The next step of this process is trying to reduce this to something that is quadratic-like. Y is equal to z minus p over 3z. So p is equal to this term divided by this term. So p, note, is equal to the -1 divided by the 2. Now, usually it's actually typically done that you divide the 2. I didn't do that, and I'll show you why I didn't do that in a little bit. So we get y is equal to z minus a -1/2 over 3z. The trick for multiplying these, we go ahead and do that. So we get z plus a 1 over 6z. And now, like we did with y, we'll plug this in for y. So we get, okay, great. Let's go ahead and let's distribute. So I notice I've got a z that cancels here, and then I've got a 1 over 6z that cancels here. I said something quadratic-like, and right now we don't have that. But if I do this, multiply everything by z cubed, then I can do 2 times z to the 6th. This will cancel, and we'll just left with plus 108, so 1 over 108, pardon me. And then I have minus 2z cubed. I just rearrange the terms. And then for good measure, let's go ahead and actually, should I divide by 2? I think I need to, because we're going to use the quadratic formula. Notice we have 2 times z cubed squared minus 2 times z cubed plus 1 over 108 is equal to 0. Okay, so we have it in the form of z cubed. Well, so that means z cubed is equal to Okay, so first of all, let's do this. Let's separate this into 18 over 36 plus or minus root 318 over 36, and then this can cancel to just be 1/2. Now we're going to go ahead and take the cube root. And initially, we'll just worry about the principal cube root, and we'll worry about the other cube roots at the end. So this just becomes z. We get the cube root of 1/2 plus or minus root 318 over 36. Now, we have to simplify this somehow, because remember, this is z. This isn't x yet. So let's note that y is equal to z plus 1 over 6z. And then let's also note that x was equal to y plus 1. This implies that x is equal to z plus 1 over 6z plus 1. So let's go ahead and set up that equation. We have x is equal to cube root of 1/2 plus or minus the root 318 over 36 plus 1 over 6 times the cube root of 1/2 plus or minus root 318 over 36 plus 1. Okay, now the trick here is to simplify this. Now, to make this as simple as on ourselves as possible, first, I'm just going to go ahead and worry about the plus. Let's just do that. We're doing this in pieces. Next, look at this and work on simplifying this. So I'm going to go ahead and I'm going to do, and on the next page, 1, what is wrong with my pen right now? So 1 over 6 times the cube root of 1/2 plus, if we do this with the minus, it'll be the same idea, cube root of 318 over 36. And what I'm going to do is I'm going to make that 6 I'm going to make it cube root of 216 times the cube root of 1/2 plus root 318 over 36. Now I can join the two together. 216 divided by 2, this will equal, okay, 1 in the numerator, the cube root of 108, okay, plus 216 divided by 36 would just give me over 6. Okay. Well, no, sorry, not 6 in the, it would be 6 with the root 318. Okay. Now, there was a trick I learned, and it's actually quite handy. I wanted to multiply this by its cubic conjugate, is what I like to think of it. But then I saw a trick, and it's actually multiply it just by the conjugate of what's inside here, all under a cube root, of course. So what we're going to do is multiply the cube root of 108 minus 6 root 318, all divided by the cube root of 108 minus 6 root 318. Okay, so we'll get cube root of 108 minus 6 root 318 in the denominator, okay, or in the numerator, pardon me. And then we're going to go ahead, I'm going to do a little fast forward editing to get what that is. So and so what this leads us with is the cube root of 216, which is cube root of 108, 108 glitch minus 6 root 318 divided by 6. Okay, so let's go ahead and transfer this to a new page. I'll do a quick cut. Okay, so I rewrote this first cube root as the original before I split it off and simplified it. I realized I shouldn't have done that when I was setting this up. So because now I can multiply both top and bottom by 6, so I get x is equal to the cube root of 18 times 6 is 108. There's our magical 108 again. Plus, and of course, now, if you go back and watch my cube root video, it's been a while, but I'm pretty sure I factored out the 1/6 here and just set this equal in parentheses. I'm not going to do that this time just because it doesn't really make much sense to do that extra work. So this is the principal cube root of the whole thing. Now, how do we get the two imaginary solutions? Well, let's really quickly talk about the cubes of the cube roots. So this would be built on the principle, I'll use a different variable, cube root of a being equal to 1, the cube roots of unity, okay? We would solve this by cubing both sides and then subtracting 1, and then we would use difference of cubes, which would lead us to a minus 1 times a squared plus a plus 1, pardon me. Had a brain fart there for a second. We get a equals 1. Oh, forgot the I. Okay, so what we're going to do with this is we are going to go back and we're going to work this into our solution. Now, the way I've got it written is I'm going to write them both out at the same time because there's a way we can simplify this so I don't have to write it. They're kind of long solutions. Well, I'm going to actually lead with the 1 plus because that's how I have it in my cubic formula video. And then think about this 2 being multiplied by these 6's. And I'll go ahead and that'll give me 1/12 and I'll factor it out. Now what's effectively going to happen is I'm going to take each of these in combination and I'm going to multiply them, now working just with the numerators, by these numerators right here. So if I write cube root of 108 plus, looks like I forgot a 6 right there. There we go. Did I forget it over here? Nope, I'm good. Okay, so 6 root 318. I apologize to the people who are probably screaming at their screens. All right, then we multiply by, now for beginners, I'll just take the -1. -1 plus I root 3 and close it. Okay, and actually, I think I'll make this a bracket instead. Let's make that a bracket, okay. And then we go with, okay, so then it's plus cube root of 108 plus 6 root 318. Actually, now it's minus, pardon me, because we got the conjugates in there. Okay. And then multiply it by the other one, the -1 minus I root 3. And then we'll close the bracket. Now, that would be one solution. That might be x sub 2. To get x sub 3, what we're going to do is I'm going to put a minus here and a plus here. The fact that I started with the plus here means I go with the minus here. And then if I were to put a minus here, the plus would go there. Let's go ahead and check my solutions from the cubic formula video to compare. All right, now in retrospect, I'm now realizing that I did forget a plus right here where this should be minus and this should be plus. But all in all, it looks good. Now, one thing I did notice was the 108 in my cubic formula video was a negative, which initially freaked me out when I was reviewing my solutions, but I also realized this +1, or this -1 here was a +1 in the previous video. If you imagine for a second we factor out a negative, then this plus minus here effectively flips, and we could factor this negative into the cubic, and it becomes -108 minus 6 root 318. And then over here, we would get a plus minus, and we would get -108 plus 6 root 318. So for all intents and purposes, I believe those are the same solutions. If you don't think so and you have a different thought, let me know down in the comment section. Thanks for watching.